artificial intelligence.
Our next speaker is here to talk about building humanity first AI for the 22nd century. He's an ML researcher at Algoverse and founder of a non-profit startup, Trinity Education. Ladies and gentlemen, please welcome Mr. Haihao Liu.
That's kind of how I'm going to structure my talk, talking about both of these parts, the humanity first AI in the 22nd century. So as I was introduced, I'm the founder and CEO of Trinity Education, as well as a machine learning researcher at Algoverse, which is, well, you'll hear more about it later. So I'll say a little bit about me first. I'll try to keep this brief. I'm from China originally, grew up in the US and Hong Kong. I did my undergrad at Rice University, and I got dual degrees in material science and in math. And during my undergrad years, I experienced diverse research experiences abroad, all over the world. You can see Japan, France, and China. After that, I started graduate school at MIT, a PhD in material science and engineering, but through a stroke of fate, I'd say, I ended up doing research on machine learning rather than something math or physics related. I qualified as a PhD candidate in 2020, just before COVID. Things didn't quite go to plan, let's just say, but I'm currently completing my Master of Science. Then things took another left turn, and I decided to pursue one of my other real passions, which is education. And so I applied to the other school down the street in Boston, and for a Master of Education in Learning, Design, Innovation, and Technology. And my interests are in the neuroscience of learning. So given this background, I think it's fair to say I'm not sort of your typical builder or engineer that you have in mind, compared to some of these other amazing speakers. But I like to think, given this background, I think of myself as a builder of bridges, right? This is partly just my own upbringing, right? Growing up in these very different parts of the world, doing research abroad, even now coming here to Nepal, right? Which is an amazing country. But also between different communities. And I want to, shoot, that's not the right version. I want to that's kind of how I'm framing my talk today, right? I come from this academic background, but as you can see here, I'm also a founder, a builder of this startup. And I want to encourage through my talk, like the value of building these bridges between different communities, between the builders, between the entrepreneurs, the academics, and the researchers, and to see the value in that. This is a pretty academic model of what I'm talking about here, but you can see it's called the triple helix model between university, industry, and government. And I don't know if there are any government representatives here or even people working in policy, but if you're interested, this is kind of the model of what I'm talking about today and what I'm trying to encourage, this synergy and interaction between. So first, humanity first AI. What does that mean? And I want to quickly ask, who here is familiar with Asimov's 3 laws of robotics? A few hands, a few hands. The 3 laws of robotics. Who knows that there's a 0th law of robotics? Anyone? No, okay. So quick refresher, the first law of robotics is that, this is from Isaac Asimov's Robot Foundation series, which is science fiction, but it's really inspired a lot of real-world stuff too. But the first law of robotics is that a robot cannot harm a human through action or through inaction. And that was the first law of robotics. Now later, in some of the later stories, the stories are a lot about the conflicts between these laws, right? And Asimov added what he calls the 0th law, because this supersedes even the prime law of not harming a human. And that's that a robot may not, through action or inaction, cause harm to humanity. And that's kind of the inspiration of why I use this term humanity, right? You hear a lot about human-centered AI, human in the loop, human first, and these are all great, right? We should be thinking about those things, especially if you're a designer, you're building a product. But I invite all of you to also think about these broader implications, right? The implications on all of humanity and on all of society. This is from a recent talk. speaker there is the dean of the MIT School of Humanities, Arts, and Social Science. Now, you probably don't think of MIT, you don't think of humanities or arts, but actually MIT does have a quite an incredible faculty there in doing stuff in economics and philosophy. And he's the dean, Augustin Rayo. And this was at a recent alumni event where he says, MIT should educate the top engineers, but today you can't be a top engineer unless you understand the human implications of your work. This is another book from one of the labs at MIT called Failure to Disrupt. Now, you hear the word disruption a lot, right? Especially in the startup space, the Silicon Valley, right? It's all about disruption, disruption. And now this book is titled Failure to Disrupt, with the subheading, Why Technology Alone Can't Transform Education. So he's talking about education in particular, but I think this applies more generally, right? There tends to be this mindset that like, oh, AI or even any technology can come and solve education or can solve climate change or can solve, the financial, solve poverty. And frankly, that's not the case, right? Which is why we need to think about the human aspects and the humanity. So this idea of AI for humanity, I recently met, he's an AI researcher and think tank leader. He's been working in AI since his PhD in the 80s. But they wrote this book, AI for Humanity, and this is the idea. I think it really captures, what I mean when I say humanity first, right? AI, a manifesto for a future where AI amplifies humanity's potential and creates a fairer world for all. And this is not just some, niche idea. This is very recent. You can see this was in October. The UN University, which I didn't know they had a university, but this is the UN University in Macau, and they held this AI conference 2025. And the theme of the conference was AI for Humanity, building an equitable digital future. And I actually spoke at this conference at the invitation of Dr. James. Oh, he's one of the co-authors of that book. And we spoke about this idea of AI for Humanity as SDG number 18. So many of you probably know there's 17 Sustainable Development Goals, and part of the idea in that book is to advocate for AI for Humanity as this like overarching 18th Sustainable Development Goal. This is from my hometown, where I currently live, of Hong Kong. And this is an example of what I'm starting to talk about, right, between academia and industry collaboration. So this is the AI and Humanity Lab. I'm not like a professor or anything at HKU. I have a friend who is, and he's one of the PIs at this lab. But there's a course, a new course earlier last year about AI and ethics for a new degree program. I forget the full name, AI and Ethics and Society, something like that. But I was an industry sponsor, industry partner, collaborator as Turn-D Education, where we're thinking about like the ethics of AI in education systems and students using AI. And the very interesting thing, I don't know if you can see down here, it's a little small, but this lab is based in the Department of Philosophy, right? You might think, well, AI, that's such a technology thing. Why is it philosophy? And so this just again goes to show the interdisciplinary, the importance of that. And this is an article I saw recently. Philosophy has never left the building. The myth of merely practical thinking, right? I think a lot of you perhaps in the audience, right, as builders, as engineers, right, you have this like very practical mindset, and you might scoff at something like philosophy. You're like, oh, that's just, the ivory tower academics thinking about, these things. But I challenge that, right, and I'll try to show through some examples why this is actually still very important. So this is one thing you could say built, but I helped start. This is a digital magazine run as a writers collective called Phi AI. The Phi stands for philosophy. There's a QR code if you want to check it out. And this is AI through a humanistic lens. We ask deeper questions about intelligence, ethics, and the future. And hopefully this works. This is a snippet from a recent podcast format that we did for this online magazine.
The question of, right, what should we focus on, right, the short or this long term? That's also been a really interesting question that I've discussed with some people, because To me, I think that one of the critiques I have of like the AI safety field is it focus on these existential risks, right? The potential for causing human extinction, right? Which Akin said, like some people believe is 2 years away potentially, and so and I would challenge them, and be like, what about the harms that are happening now? And one that I definitely want to make sure I bring up today is the environmental. And that ties very closely actually with the regulation aspect, right? The regulatory aspects of that. And the responses I usually get are either that's negligible compared to human extinction, which is like, oh, but like, that's where the quantifying thing happens, right? Like if human extinction, okay, we can value that arbitrarily large and negative, even if it's not negative infinity, it's some arbitrarily large negative outcome. So that even if the probability of that is arbitrarily small, it can, just by math, it'll like, right? And that's one of the things which I disagree with, like trying to quantify everything. That's one of them. And then the other one is like people are like, once we have AGI, it'll solve climate change for us, which I think is just like wishful thinking. Right.
It will either kill us or solve everything. Yes.
Yeah, exactly. And so I think that's an example of one area where I strongly believe we need to have more focus on regulating now.
That's just a estimate of some of these issues that I hope and I encourage all of you to think more about, right? The implications on, in this case, the environment. And who here has heard of like the AI safety field, which I mentioned just now? Like AI safety, yeah. And I don't know like what your perceptions of it are, but in the mainstream discourse, a lot of it tends to be what I mentioned just now in that clip, these existential risks, right? Catastrophic risks to humanity, superintelligence, you might have heard. And there's, now, I'm not completely writing those off. I'm not saying like, oh, that's complete science fiction, that can't happen. But I believe it's just as important to think about these harms that are happening now and the risks that are happening now. So this is an article, AI Safety for Everyone. And another thing I'm building, I'm really trying to sell myself as a builder, but we'll see if that is AI Safety Organization in Hong Kong, where we have this idea of AI safety for everyone. So it's not just these AI researchers working on the frontier models, trying to align it with human values. That's the AI alignment problem. But and preventing existential risks, but also a lot of these suffering risks that are sometimes called, or just harms to risks, present risks and harms. All right, now the second part. So for the 22nd century, and I want to first explain a little bit like the origin of this, how I thought of this idea. So when I was first starting out with the idea of turnkey education, I was doing a lot of reading a lot of philosophy actually. And so this mathematician philosopher, Alfred Whitehead, wrote nearly 100 years ago, right, The Aims of Education and Other Essays. I suggest that no system of external tests can result in anything but educational waste. Now, who here has taken tests in school or in college, or a lot of like standardized tests, I guess, right? Like I think we all have. And we've known for a long time, the limitations of that, the flaws in that, right? Of just basing, like in China, I'm not sure how it works in Nepal, but like, you've probably heard in places like China, like your entire life is determined by that one exam, right? The Gaokao exam, right? And yet, 100 years on, we're still, with these systems. And so that's why I had this idea, like, what I'm trying to work on, right? These really big picture ideas, trying to move humanity towards a better future. Like that's gonna last longer than my lifetime, right? So that's why I had this idea of education for the 22nd century. And part of that means education for the future workforce, right? So that's part of what my company, Turnkey Education, does. And we talk about AI literacy. And people might have this idea that AI literacy is this thing that just, since ChatGPT, people are talking about it. But actually, AI literacy is a lot of these things that have been around and have been talked about for a long time, right? You've probably heard of digital literacy, right? Media literacy. These are all aspects of AI literacy. And we can't forget about, like, the foundation of AI, which is the computer science, right? These models are fundamentally, right, these mathematical models and algorithms. But then we also have design thinking, which my previous talk was really talking a lot about, which I appreciate, right? This is all part of this idea of AI literacy, of how do we empower a future workforce, right? We talk about 21st century skills. Now I'm thinking ahead about 22nd century skills, right? And one aspect of that ties again to the humanity aspect is the ethics, right? And we don't want ethics to just kind of be an afterthought, which often it is, right? Like you build this product and you might have like a ethics statement or something if you're like a company. And this is from a presentation from Margaret Mitchell. So Margaret Mitchell was the founder of the AI ethics team at Google, but she was fired for no particular reason back in 2020. And this was from a talk, a fairly recent talk she gave. And it's important to understand how human bias comes in at every stage of the AI pipeline. And so this, again, like why are we talking about the 22nd century, right? It's about sustainability, right? We talked about AI for humanity as the 18th sustainable development goal, right? If we want to make it to the 22nd century, right, we have to be thinking about it with these long-term goals. And so back to the 21st century, right? What are some of the things that you often hear when you hear about AI, right? I'm sure this will sound familiar, right? People talk about faster scaling and growth, 10 times worker productivity, supercharge your business, speed up grading, accelerate your learning, right? These all sound kind of familiar. And the big one, right? This is the sort of the mantra in Silicon Valley: move fast and break things, right? And maybe some of you believe these things are good things, right? And I'm not saying that these things are all completely bad, but just like some of the previous talks talked about, right? By doing this, it isn't like all good things, right? There are also, this is the key, right? Move fast and break things, because things do break, right? And that's what I was talking about with the harms. So, if there's one takeaway message, right? Like. All this, one takeaway message from my talk today, I encourage people to slow down, right? Now, you've all heard, I'm sure, the fairy tale, the tortoise and the hare. Yes, I hopefully see some, right? And what's the moral there, right? Like, moving fast doesn't necessarily mean you win at the end, right? Maybe actually slowing down will mean you win in the long term, right? Again, we're thinking the future here. This was partly inspired by something that I saw almost 10 years ago now, the Slow Science Manifesto. You can look it up. This was a group from Germany, I think, who started this. And I want to highlight one particular. We do need time to think. We do need time to digest. We do need time to misunderstand each other, especially when fostering lost dialogue between humanities and natural sciences. We cannot continuously tell you what our science means, what it will be good for, because we simply don't know yet. Science needs time. And I think this is very apt for the age we're in right now with AI. Some of the other speakers talk about how we're really at this, we've comparing it to the early days of the internet, comparing to, any early days of technology. We simply don't know, right? And now, a lot of people will, especially maybe we should speak to an investor or something, you have to at least sound like you have all the answers. But as scientists, right, and this is from my training as an academic, right, you have to have that humility to say, like, we don't know, and we need time to figure it out. And again, I'll say, kind of use an example from my background, what I'm familiar with academia, of how like this moving fast doesn't necessarily mean we're doing better, right? And so I'm sure you guys, some of you might have heard of like Sakana AI and deep research, and even the AI CEOs like sort of Sam Altman, they're all talking about like AI automating research and like accelerating. But that I worry that that's not necessarily a good thing. Right, and part of that, if you've ever if some of you gone to grad school, if you've done research, like that's just the sheer volume of papers that are coming out now, right? Especially in AI, that can actually be a hindrance because there's so much noise, right? And you have to separate the signal from the noise. And so, what would be a potential benefit of slowing down, or like of not just accelerating by publishing the lowest hanging fruit, if you will, right? Which happens a lot in academia. So who's heard of neurosymbolic AI? A few hands. Okay, not too many, right? And this is starting to, you can see this was from August last year, right? This is starting to become a little more mainstream because people, especially after GPT-5 came out, people were realizing like, oh, like maybe LLMs isn't the entire future, right? Or all there is to AI. And so this is a neurosymbolic AI, but the idea there is you're combining these two paradigms of AI, the deep learning, the artificial neural networks, with this older tradition, often called symbolic AI, right? And so it's combining here. But this is an example of where, like, if you have this connection, or even, if you're talking to someone from like a researcher in academia, if you're not one yourself, right? You can see this was from 2019. This isn't a new idea. Of course, neurosymbolic AI goes back much farther than that. But this is an example of the kind of thing that by taking science more slowly and just by taking the development of AI a little more slowly, we're not just chasing, the next quarter, making the next bigger model, how many data centers we build, but we can actually explore more ideas, which will end up more trustworthy, safer, better for the environment, uses less power. And so this is actually an area that I'm really interested in, neurosymbolic AI. This idea of, and this part here, learn about the world like a child, because there are certain aspects of our human brains and our human intelligence that have aspects of this neurosymbolic, where we have, if you're familiar, sort of like system 1, system 2 thinking. Thinking fast, thinking slow. Yes? No? Okay, a few more hands. Okay, good. I want to connect this, to things you've heard of. And system 1 thinking is the thinking fast, right? I compare that to the deep learning, the artificial neural network aspect of thing, where it's built on pattern recognition, right? And it works very fast. It's what system engages when we're speaking a language we're fluent in, right? It's unconscious, basically, right? It's automatic. But the system 2 thinking, the slow thinking, is what happens when you do the slow, deliberate planning or reasoning, right? If you're working through a complex task, that's the system that engages. And that's an example. So that's kind of neuroscience inspired. And so to give another, something for hopefully some of you to explore, this idea of neuro AI. And neuro AI is this idea of what we learn from neuroscience and taking it to AI, but also using AI to help us better understand neuroscience, right? How our own brains work. As you all know, like neural networks, that was the original inspiration, right? It was from neuroscience. But over the decades, that connection hasn't been as strong, I would say. And I think there's a lot of potential to explore this area, as you can see here. And see neurosymbolic AI is up there as well. And this I'll talk about very briefly. This is the other aspect of my startup's work. So we have kind of the AI literacy training and stuff, but also this is more nascent. We're working on research as well. And so this is the sorry, I'm a bit thrown off because the slide is an older one, but it's okay. So this idea of knowledge graphs, right? Knowledge graphs is one of the core ideas and an aspect of neurosymbolic AI. Knowledge graphs were very popular. I'm sure Manu can tell us about this. Very popular in like the 80s and 90s with these things called expert systems, and they were found to have very serious limitations, right? Where anything that's like it was called very brittle, right? Because anything it wasn't exactly designed for, it just like breaks completely. So this is an example of like these new ideas, right? And again, this was, for me at least, inspired originally by like learning about how the human brains work. And we have these things called memory schemas in our minds, which are kind of how we relate concepts, and that maps very well to this idea of a knowledge graph. And looking at the time. So I'm gonna wrap up with some hopefully more practical lessons from research for the broader builders audience. This is the target audience of this conference. And I'll talk about some of the research that I did with Algoverse, which I it's a program for mentoring high school and undergrad students to do AI research. And so I'm not going to go in detail about the research because the idea here is I'm using some of the themes, if you will, of the research and distilling them or extracting from them some more general ideas. But if you're curious about the research, talk to me later if any of these particular directions. So this is one about skin cancer detection through reverse scale divergence distillation. Don't have to worry about details, but some of you might have heard of knowledge distillation, right? You take this larger model and distill it to a smaller model. So one key here is bigger is not always better, right? And this ties back to the neurosymbolic idea. And also, you might have heard now about like smaller SLM, sometimes small language models, models that can be locally run. I like I'm sorry if I'm getting your name, but the example of like, you don't always like need to use an LLM, but actually have a specialized model, right? So that's one hopefully helpful takeaway. This is another paper recently presented at NeurIP's workshop last month. And the basic idea here is you hear a lot about AI or LLM evaluations, right? But what we often is a problem is these evaluations are set up in a way that doesn't reflect how they're used in the real world. Like they're very artificial, right? They're like tests, right? And a behavior that's been observed is something called evaluation awareness, where you can actually measure when the activations in the neural network that they seem to they behave differently when it perceives it to be a testing environment versus a real-world deployment environment. And so this paper is about how do we rewrite these evaluations to better reflect how LLMs are used in real life so that the behavior of the model under a testing condition hopefully more accurately predicts how they will behave in the real world. And so one takeaway here, hopefully to generalize, right? Testing of whatever you're building, a product or stuff, has to reflect the real world. This is an interesting one. It's a bit difficult to explain, but the key word here is unwittingly compromises safety. So what happened here, in short, is that we were trying to do this to make a model safer. Turns out it actually made it worse. But rather than just like, oh, this failed, right? We still we looked into why this happened, right? And maybe something interesting is going on there. And so embrace unexpected results. And finally, this is one we just submitted, tracking the emergence and evolution of misaligned traits. And the takeaway from here, I'll just get to the point, is monitor, right? This is in the case of a fine-tuning LLM, but I think this applies more generally, right? This is, again, I was inspired by the talk where like you catch the problem early, right? When you have 100 documents rather than when you've done 140,000 documents. And now this is the last slide, I promise. I've been sharing about how hopefully lessons from like research and academia and how that can help builders and engineers and founders. But this is one where it's kind of the other way around, right? Because you hear this word iterate a lot, right? Iterate when you're a startup and we're designing a new product. And this is again the same author, Justin Reich, where his other book is called Iterate: The Secret to Innovation in Schools. And I feel like we can take that lesson for me personally too, right? To not have this mindset, oh, like it needs to work perfectly. I have to, design it, plan it perfectly before, right? But just like try to build something and see what happens, and then iterate. And I just want to leave on this note because, again, the point is I want to build bridges and connect people across countries, across disciplines, across fields, and together we can build a brighter future for all. Thank you.